Welcome to This Explainer. Today we are unpacking a highly provocative claim from a channel called Buried Secrets. They're talking about a supposedly suppressed 200-year-old technology that could, apparently, give us free electricity. Imagine that for a second. No more power bills, zero dependence on massive utility corporations. The source talks about these DIY thermogenerators that you can essentially just build on your own roof. But we have to ask, is it actually true? Can you really charge your smartphone or power your lights using a few basic cables from the local hardware store? Well, today, we're going to break down exactly what the source is claiming, the actual physics behind how it works, and most importantly, whether this concept is practical for everyday use.
Here's our roadmap for today. We'll start with the mystery of thermogenerators, break down the physics of the Seebeck effect, look at a practical DIY guide, ask if this works for everyday use, compare it to commercial solar panels, and finally, figure out if true off-grid autarky is a reality or a myth.
Section 1. The mystery of thermogenerators. The source material kicks off with a massive, emotionally charged premise. They argue that the global electricity distribution industry makes $400 billion a year, and therefore has a vested interest in hiding a simple, free alternative from the public. Looking at the timeline they present, the story supposedly begins in 1821. That's when physicist Thomas Seebeck held two metal strips, copper and bismuth, together, warmed one side with his hand, and created an actual electromagnetic reaction. Fast forward a huge leap to 1902, when an engineer named Wilhelm Hahlwachs supposedly used ordinary zinc roofs to apply this effect on a much larger scale. But then, according to the video's narrative, 1923 brought a dark turning point. That's when power companies began their aggressive worldwide expansion, blanketing Europe with cables and meters, and deliberately erasing the idea of decentralized, independent power from the public consciousness. Section 2. The physics. Let's look at the Seebeck effect. The core concept here is actually brilliantly simple. It's a fixed principle of thermodynamics that you literally cannot patent or ban. The Seebeck effect means that if you join two different metals at their ends and then create a temperature difference at that junction, so making one side hotter than the other, an electrical voltage is automatically generated. The thermal difference literally moves the charge. As the video emphasizes, there's no fuel required, absolutely no complex chemical reactions, and no moving parts to break down. It is pure, unalterable physics. And just think about the sheer elegance of using the natural shift from day to night. The source points to the historical records of Wilhelm Hahlwachs to demonstrate this. A simple zinc metal roof in the blazing midday sun can easily hit 70 degrees Celsius. Then, in the dead of night, it cools down to about 10 degrees. That is a massive 60-degree temperature difference over the course of a single day. Hahlwachs supposedly harnessed this natural heat shift using copper and galvanized iron strips, which resulted in 12 hours of continuous, uninterrupted power flow. No human intervention needed whatsoever.
Section 3. Our DIY guide. Power from cables.
Okay, let's dive into the practical setup here, because the source actually provides an incredibly specific DIY guide using just the most basic hardware store materials. You just need to cut 1 meter of 14-gauge copper wire and 1 meter of 16-gauge galvanized iron wire. Next, you take the ends on one side and twist them tightly together. This becomes your hot junction, and that goes on the sunniest part of your roof. You leave the opposite ends of the two wires separated. This is your cold junction, and it absolutely must stay in the cool shade. Once the sun hits that twisted connection and creates a temperature difference, you can literally take a multimeter and measure a voltage. But here's the real kicker, the price. The source claims you can build this initial experimental prototype for less than 55 Mexican pesos. To put that in perspective, that's literally just a couple of US dollars. The financial barrier to testing the Seebeck effect yourself is practically non-existent. Section 4. Is this enough for everyday use? Let's talk practicality. Now for the critical reality check. If you build that exact setup we just talked about and generate a temperature difference of about 30 degrees Celsius, a single pair of copper and iron wires will only give you between 0.2 and 0.7 volts. That is remarkably low. I mean, a standard AA battery has 1.5 volts. But here's the absolute crucial point. Voltage isn't the whole story. For actual usable power output, the amps, the electrical current, is the true bottleneck. And with simple, thin hardware store wires, the flowing current is incredibly tiny. The electrical resistance inside those cheap cables instantly eats up the minute bit of energy you've just generated. To solve this incredibly low voltage issue, the source suggests a workaround: summation. Since one pair gives you roughly 0.7 volts, you just connect multiple pairs in a series, exactly like stacking batteries inside a flashlight. The video claims you need about 20 of these twisted wire pairs chained together. Do that, and you add the voltages up to reach between 4 and 14 volts. That happens to be the exact threshold needed to slowly trickle charge a phone via USB, or maybe run a small LED emergency light overnight. So yes, it is technically feasible for tiny devices, but suddenly you're looking at managing a rather massive wire mesh. To back up the underlying potential of all this, the video cites 2017 research from Freiburg University. Scientists there showed that an incredibly dense matrix of specialized thermocells, under a 50 degrees Celsius difference, can produce up to 120 watts per square meter. That is significant. It proves that the science is entirely real and highly capable in optimized laboratory environments. But, it also highlights the massive efficiency gap between top-tier lab materials and a DIY wire project on a residential roof. Section 5. Thermocell versus commercial solar. Let's compare. This comparison perfectly captures the source's ideological stance. On one side, you have commercial solar setups costing anywhere from 55,000 to 145,000 pesos for a home. The video argues this just creates a new kind of dependency. You need specialized technicians, expensive inverters, and you're locked into warranties and grid contracts. On the other side, you have the DIY thermogenerator. It costs just 55 pesos to start. Literally anyone can twist wires together, and it uses basic ambient heat. The source paints a very sharp contrast here. While modern solar keeps you tied to a corporate system, cheap metals and pure thermodynamic laws represent true independence. Section 6. True autarky or myth, the final verdict. So the big question, can you completely leave the grid using this method? Well, the video ends with a pretty powerful anecdote about a camper in Oaxaca, Mexico. For just 160 pesos, he supposedly built a wire pair system that independently powered his lighting for 2 entire years. The quote they use here, "Physical laws have no price," is really the emotional core of the source material. It's presented as an act of quiet rebellion. It isn't just about saving money. It's about reclaiming control and utilizing the free energy all around us, entirely on our own terms.
And that brings us to the ultimate takeaway. The physics, they are undeniably real. The Seebeck effect works, and with enough copper and iron wires wired in series, you absolutely can run small LED lights or charge a phone. But when you look at the brutal physical limitations, specifically the incredibly low amperes and the high resistance of the cables, running a modern home with a fridge and a computer would require an unimaginable, sprawling web of hand-twisted cables. It's a fascinating emergency fallback for sure, but is true energy autarky really worth the manual labor of maintaining hundreds of twisted wires on your roof? It's a question that pits our love for modern convenience against the ultimate dream of going completely off the grid. Thanks for joining us on this explainer.